My name is Stephanie Miller, and I am a postdoctoral scholar in the lab of Dr. Jorge Palop. As a kid, I was definitely interested in science. This began when I was pretty young. One of my favorite hobbies would be to wander around in the woods behind my house and just turn over every log and rock in order to find salamanders and other little critters. A good time for me was, building little homes for them and sort of like watching them. We'd keep them in a little terrarium on my back porch for a couple days and then return them to the wilderness. So that was probably an early sign. Later, as I began to become a teenager, I just really loved science fiction. That also was part of my path. Importantly, actually, I began to read science nonfiction, especially some popular science novels. For example, the novel, or I should say, the book Chaos by James Gleick, which is the story of how the science of chaos really was born in the 60s and who the major players were. And it was like a best-selling book. So I was captivated. And at the precocious age of like 13, I wanted to grow up and be a fluid dynamicist, which is a new one. And actually, I haven't actually landed so far from that initial dream. And my path that has brought me to systems neuroscience at Gladstone has included formal training in the physics of non-equilibrium dynamics, which is what you call chaos these days. In the Palop lab, we are studying why brain waves become disorganized in Alzheimer's disease. We study the cortex, which means bark, and it's the outer layer of the brain, which is where we do our thinking, for example, and lots of other higher order processes. And most of the cells in the cortex are excitatory cells, but about 20% of them are inhibitory cells, which function sort of like stoplights. And so what we find is that in Alzheimer's disease, some of these stoplights get their timing messed up. And we're trying to find ways that we can treat or rescue the timing of these stoplight cells so that the entire brain can recover healthy coordination. We'll know that we're onto something when our treated disease model mice exhibit behavior that is similar to the wild type healthy mice. I love organizing at the intersection of communities. I have a long-standing hobby of advocacy in science and in marginalized communities. And because I myself, as a mixed race person and a queer person, stand at the intersection of many communities, I just really would like to use my energy to help build and strengthen coalitions between communities who share common goals and can support each other. If I could learn to do anything, it would be to observe myself better. What I really wish I had is a readout of my own brain signals at all times. That would be very helpful for understanding myself better. And I think even hobbies that I already enjoy, for example, trying to remember how to play the cello, which I once played when I was young, and I now have, and I occasionally pull out and will pluck a bit and play some of the old songs that I used to know. It would just be so cool if I could see my brainwaves while I'm playing the cello or doing something, like, research, or even something like gardening or, sort of trying to exist in a mindful state. I really appreciate sort of like metacognition and understanding myself better.